Hello, everyone. I'm Dr. An. Matplotlib is one of the most popular Python data visualization libraries and is indispensable to machine learning tasks. This module will cover all you need to know about Matplotlib, which allows you to start immediately by performing machine learning and artificial intelligence tasks. Let's dive into the Matplotlib programming tutorial right away. Hello, I'm Dr. An. Now let's dive into Matplotlib basics for machine learning. First, I'm going to import Matplotlib together with NumPy. I used import matplotlib.pyplot and I called plt. So the pyplot is a submodule of Matplotlib. Most likely when we do data visualization using Matplotlib in Python, we call pyplot. And we will call it plt for short as a convention. At the same time, I'll also import NumPy as np because we are going to create some data for the plotting. And now let's take a look of the anatomy of a figure. And most of them are self-explanatory. For example, we can have a line here. If we do a line plot, we can also superimpose the dots by doing a scatter plot. And we see those dashed line and the grids, both horizontal and vertical. We can have a legend denoting the different lines or other plots in the figure. And we can also have major tick and minor tick on both y-axis and x-axis. We may create spines, as spines are created by default, but you can also remove the spines in case you want to simplify your plot. And you also have the entire figure and axis. So AX, EX, the axis is potentially unique for Python. I don't think you have access in the ggplot2 in R or visualization tools in SAS or Stata. And you can consider axis as a subplot that is in the figure. So therefore, you can have multiple axes or multiple subplots all belong to the same figure. And there are at least 3 ways that you can create a figure as well as axis, meaning sub-figures. The first way is to create an empty figure with no axis using the plt.figure command. The second way is to create a figure with a single axis, basically a single subplot, using the subplots function, but without providing any argument. And if you use the plt subplots command, that command is going to create a table. So therefore, you need a figure as well as x to store the figure and axis created by the subplots command. If you want to create multiple axes in the same figure, you just need to specify how many axes you want to create along the row and along the column. So here I'm going to create 4 subfigures, meaning axes in the same plot, in the same figure. And I want 2 rows and 2 columns, so a total of 2 by 2, basically 4 subfigures or axes in the same figure. And as you can see, what you are going to create are 4 empty axes or sub-figures in the same figure, 2 rows and 2 columns. You can also create the axis one by one, and also that allow you great flexibility to work on individual subplot or subfigure within the same figure. So there are two ways to create a subplot, the subplots in the figure one by one. The first way is to specify, use the subplot command and also specify in the argument the number of rows and number of columns of subfigures, and then denoting the specific subfigure you want to work on. So by specifying 2, 3, 1, it means that you are going to create a figure consisting of 2 rows and 3 columns of axis. And now you are working on the very first subfigure or axis. So the subplot are going to create the rows and columns from left to right and from top to bottom. So therefore, this is the first subfigure you create. It is the second, the third, and fourth, the fifth, and the sixth. And therefore, 2, 3, 1 means that I'm going to create 2 rows and 3 column figure, and currently I'm going to work on the first subfigure here, or axis. And by the same token, you can work on create the second subfigure, the third, the fourth, the fifth, and the sixth respectively. The second way to create subfigure or axis is to be more explicit, using comma to separate the row and column and also the axis number. So both ways, you are going to create exactly the same figure and axis. So it's more of a personal preference which way you want to follow. There are 2 different approaches to create figure with contents. They are called, the first way is called the object-oriented interface, and the second way is called the pyplot interface. So the syntax differed to some extent, but it's more of a personal preference, which way you want to create a figure with contents. I would say the object-oriented interface is possibly more Pythonic because, as you know, Python is an object-oriented language. So in the object-oriented interface, you regard the figure and axis as object. So you are working on the axis as an object, basically applying functions and method of that object, whereas in the pyplot interface, it's a little bit simpler, but it's not so Pythonic because you are just calling the plt plot function, not on the figure or axis object. So that illustrates the first approach using the object-oriented interface to create figure with contents. First, I'm going to generate some data for the x-axis using the NumPy linspace function. So in the function, I start the beginning data and the stop data, and also the total number of observations I want to create. Using linspace, I'm going to create a total of 100 observations that are equally spaced between 0 and 2. And second, I can utilize the plt subplots command to create the figure and the axis, because I'm going to create just a single figure with a single axis, so therefore I do not provide any arguments here. And then I can work on the axis. Remember, axis is just a subfigure because we only have one figure and one subfigure, so this is equivalent as working on the figure. And I'm going to plot my data on this axis object I created, and I'm going to provide the data for x-axis and data for y-axis. And I'm going to also provide the argument for label, which is linear. By providing the arguments to label, the Matplotlib is going to automatically create the legend for you based on the label data. So here is just a 45-degree line of x with x itself, but I also want to create another line and superimpose that to the same axis. So basically, you can do multiple plotting on the same figure, subfigure. So here, I'm also going to plot x together with x squared, and I'll label that quadratic. And finally, I'm also going to plot x and x cubed, and I'll label it cubic. And after that, you can also optionally set the labels for x-axis and the y-axis using the setXLabel and setYLabel function. And finally, you can also optionally provide a title by using the setTitle command. Finally, you probably want to add a legend using the legend command. And as you can see, this is the figure that we created. As you can see, we have the x label, y label, the legend for the three lines, the linear, quadratic, and cubic line we created together with the title of the plot. And automatically, Matplotlib is applying different colors to differentiate between the three lines. So the second way, as we said, is to create a figure with content using the pyplot interface. So the syntax is a little bit simpler, but it's probably not so Pythonic because we are directly utilizing the plot function on the data. So here we first plot x and itself and label it linear, and plot x and x squared and x as x to the cube. And also, I specify the x label and the y label. Notice here in the object-oriented interface, we use set_x label, but for using the pyplot interface, we use the x label command instead. Same for y label instead of set_y label. And same for title, instead of using the set_title in the object-oriented approach, we use the title command instead. And then finally, we provide the legend using the legend command. As you can see, the created figure is the same as using the object-oriented approach. So it's more of a preference whether you want to use the object-oriented interface or pyplot interface. Now that illustrates more about plotting. So here, the Matplotlib can directly plot data expressed in the format of list. So here, I plot the first list against the second list. So by default, the plot is going to create a line plot for you. And what it's doing under the hood is going to look at the first xy coordinate, basically 1, 1. And the second coordinate 2 and 4, third coordinate 3 and 9, and the final coordinate 4 and 16. And then you have 4 coordinates on this two-dimensional space. They just use a line to connect those dots together. You can also format the style of the plot. There's a large number of arguments that you can provide in the Matplotlib functions to customize your plot to make it more elegant or simplistic, or in terms of publication quality. So there are much that you can explore, but here we just introduce you the bare basics to help you get started. So there are multiple ways that you can provide those arguments to fine-tune your plot. A simple way is just to use a string. So here I illustrated that you are still doing this plot of these two coordinates, x and y, in the format of a list. And you can, instead of using the default line plot, you can specify that you want to change the color from the default blue to red by specifying red. So R stands for red, and then O stands for, as you can guess, dot. So therefore, by simply providing this string as an argument, I've changed the default blue line plot to a red scatter plot. So as you can see, the dots are in red color, overrunning the default of a blue line plot. You can also optionally define your range for the y-axis and x-axis. Following the convention in the list, you specify x-min, x-max denoting the range for x-axis, and then y-min and y-axis specifying your y-axis range. So you provide this as a list in the access command, and then as you can see that the resulting y and axis are specified based on your specific range. And pyplot make it very easy to superimpose multiple plots on the same figure. So previously, when we illustrated how to make plot with content using the pyplot interface or using the object-oriented interface, we wrote 3 plot functions explicitly, but actually there is a simpler approach. You only need to provide the plot function once. That illustrates how you can simplify that coding. So here I created a variable called t using the numpy arange function. In that, I provide a beginning point and end point, are also the step of incremental. So basically, this is going to create a range or a list of values from 0, and then every time it add 0.2 all the way to 5 exclusive. And then I'm going to plot t with itself, and also t with t squared and t with t raised to the power of 3 on the same plot. And instead of writing the plot function 3 times, I only write it once, and then I just include the data here for this is the first pair of data, t with itself, and the second pair, t and t squared, and third pair, t and t cubed. And then you also can optionally provide the color and also the style of the line here at your discretion. So here I want to use red color. I want to use dashed line instead of the default line. And here I want to use the blue color, and I want to use square denoted by S. And here I want to use green, and I want to use triangles using this symbol. So as you can see, the created plot like this, it simplified the task of plotting because you only need to provide the plot function once instead of 3 times separately. You can also plot with keyword string. So let me illustrate this. Here I generated still using the NumPy linspace. I created 30 observations equally spaced between values 0 and 10. And I create y, which is a sign function of x. And I also created an indicator variable called x_large. So the x_large is going to be true, taking the value of 1 if x is greater than or equal to 5, and 0 or false otherwise. And then I can create a scatter plot. You just need to call pyplot scatter. To do a scatter plot, you provide the x and y data. And here, instead of using you can specify the marker type, whether it is a square or a dot or triangle. So here I want to use the marker type dot. And you can also optionally change the marker color based on our indicator variable. So if you specify equals x large, then Matplotlib is going to use two different colors for the x greater or equal to 5 versus x less than 5. And finally, you can also associate your marker size specified by s to be proportional to the value of x. So in this case, if you have a larger x, you are going to have a larger marker size. If you have a smaller x, that is going to be associated with a smaller marker size. So there are many other arguments you can try if you want to experiment. And as you can see, the resulting scatter plot is a sine function of x. And as you can see, when x is greater than 5, equal to 5, it uses a yellow color, whereas when x is less than 5, it uses a purple color. And also, if you observe carefully, you will see that those dots take different size when the x value increases, the size of the dots also increase. Here we illustrate that you can plot with categorical variable. Here we generated a list which consists of 3 strings. We call it group A, group B, and group C. And create another list specifying the values for each group as 1, 10, and 100. And now let's create a single figure. And you can optionally provide the figure size. So here I specify the figure size as 93, denoting a width of 9 and a height of 3. The reason why I specify figure size as 93 because I'm going to create 3 subfigures in this figure, and each figure is going to be square, taking a space of width 3 and a height 3, so 3 by 3. So therefore, we are going to put the 3 subfigures one by one on the same row of this figure. And now let's use the subplot function to work on the first figure. So I'm going to create 1 row and 3 columns. A figure basically fitting here horizontally, and now I'm going to work on the first figure. And in the first figure, I'm going to do a bar chart using the bar function, and I'm going to use the name, which is a list of string, and also the values. So the Matplotlib is going to create a bar chart based on the 3 categories and corresponding values. And now let's work on the second subplot using the subplot, still row 1, column 3, the second plot. And I'm going to do a scatter plot instead. So here, still you can provide the name and the names and the values correspondingly. And finally, I'm going to work on the third subplot by doing a default line. So plot is going to plot a line with the names and the values specified. And optionally, you can also provide a subtitle. The subtitle is going to sit in the middle figure. You can provide a name for the subtitle. Here I use categorical plotting. And as you can see, those are the 3 subfigures created on the same figure. And from left to right, we have the bar chart, we have the dot or scatter plot, and we have the line chart. And finally, let me quickly illustrate how you can plot photos or images that you store as a RGB type of file in your Google Drive. So first, you need to mount your Google Drive to Colab. because, well, for confidentiality reason, you do need to provide your permission for Google Colab to access files in your Google Drive. So first, you want to import the drive function from the module of google.colab. And after that, you should mount using the drive.mount function. Basically, you mount your Google Drive to Google Colab. And here, if you execute this command, a pop-up window is going to show asking you the permission to allow Google Colab to access your Google Drive. Just provide your permission, and then as you can see now, your Google Drive has been mounted to your Google Colab so that you can utilize the files saved there. Here, I'm going to read an image file saved in Google Drive using the Matplotlib, the imRead or image read function. You need to provide the full path as well as the name and also extension of your image file. So I saved my image in to Google Drive. So this probably is generic. So all of us who use Google Drive we have this type of path. And after that, you just specify where your image is saved in your local folder. So I have a folder of machine learning and then another subfolder of machine learning datasets. And beneath that folder, I have the image called doc.jpg. Make very sure that you not only specify the name of the image, but also the extension, the full extension. And then, so the image read is going to read the image file in the form of a NumPy array. So here you can take a look of the shape of the image. It is an RGB file, basically have 3 channels, the red channel, the green channel, and the blue channel. And if you print out the shape of the file, it's a NumPy array. It's a 3-dimensional, a rank 3 array, and you have 492 pixels as the height. You have 980 as the width, and you also have 3 channels because this RGB color image. And then you can plot the NumPy array as an image using the imshow or image show command in Matplotlib. And make sure that you supply your NumPy array as the input because the image show accepts the NumPy array, not raw image. As you can see, we've plotted this cute puppy in our Google Colab screen using the image show command. That's all you need to know about Matplotlib for helping you get started with machine learning. Thank you for your attention, and I see you next time.